So it seems very difficult. There are a lot of things that you need to learn to become like a good data scientist. What are the top mistakes you see junior data scientists do when they're starting in the field? And how can they avoid them, if at all?
I feel like I'm answering the same question in 5 different variations, and I'm gonna say why. Because, for example, when a junior data scientist even come to apply for an interview, for example, their main approach and their main, I would say, mistake is to get a problem and to try to tackle it with 50 different models, because it's so easy, right? Let's do import everything from sklearn and let's do model.fit on everything, and we'll see what's happening. And then you ask them, okay, okay, so you tried this, okay, this worked, okay, this one has 95% accuracy and this one has 90. Can you tell us the difference? What made this model works better on this data? Why is this the model appropriate for this kind of problem? And they often lack the basic math and basic understanding of why they are doing what they're doing. So I would say that's one of the greatest mistakes that I've seen. Like, try to put all of your heavy gear into a model without previously understanding what is your problem and what is the right approach to do so. So the basic, the core foundations that I think that data scientists must have, that's the appropriate solution. That's my opinion on that.
Of course, there are a lot of mistakes. I will just put one to the table. It's machine learning over engineering, and the mindset that the largest model is the best one. The best model is actually the smallest model which solves the problem, because it's the cheapest in production, it's fastest to build, it's easy to interpret usually, not always, because even the simplest model is maybe quite large and complex for some problems. And when you see something like, okay, we created an ensemble of several hundreds gradient boostings and all of that, and it achieves like 98 whatever, that's actually a bad sign, because combination of models like that is usually cannot be supported in production at all, because you will get into a huge mess very quickly, because models are not like live forever. You need to retrain them, update them with new data and all of that, and that's just not possible to do with that setup. There are more things, but I will just mention this one. Yeah, that's huge mistake, I would say, to over-engineer things. It's the same as in software development in general and in engineering in general. Do not over-engineer without actually a good cause.
Yeah, so to rephrase and add, I would say there are 3 basic mistakes: underfitting, overfitting. These are 2. And the third is just fitting the wrong function. Okay, and that's what I talked about before. Basically, not fitting the thing that you're actually interested in for your product. Okay, and these are things that I find happen all the time.
Yeah. I will address something else. I think the main problem of juniors is not building the right personal branding, because a lot of them, and I see it, you get a lot of questions in the community about, okay, I wish to start, or how should I make the first step in order to get an interview or get a first job? And the main problem that I see that they are not trying to share more information or keeping the personal brand to the community and helping more people to know that they are there, they are existing. And you don't have to be super genius or trying to fool others that you know, but sometimes even you are learning a new topic, or you've done a lot of research on specific, you can write a great blog post about that. Or if you are helping to run a workshop day or a lot of other activities, it could help you. And or even if you're doing a project by yourself, and then you can release the code and a cool video. So this could help a lot of people get there for a job. They all spoke about the actual programming or development. This is super important. You won't be able to get your really actual work without all this stuff, but as I see, and I get a lot of requests from people, hi, Uri, how can get my first job? And my biggest advice is trying to shine a little bit, because there's a lot of others like you are trying to get their first job or just finish this course or other course, but you can get a really nice and decent advantage if you just put yourself in the eyes of the one who want to hire you and just signal them, hey, I'm really trying to learn, I want to share, I have a passion for this topic, and it just will help you get your first job. That's it. And it's work. It's super easy to do, and it's work. Believe me, it's like a magic.
Going back to the mistakes that data scientists do, and I think that's all related, maybe one more sentence about that. I think that because the field is moving so quickly, because there are, we teach now things that were released a few months ago. We don't even, we never learned them. We had to learn them ourselves. Companies would want you because you're very smart, you're highly motivated, and you know how to learn. And this is what you need to show. And there are many ways to show that. Yeah, competing in a Kaggle competition is one of those things, and trying different things. Even writing blog posts, like Medium posts, about a project you've done, how you looked at the data, how you tackle things, the projects that you will do in the program are amazing, because you take a real-world problem and you solve it somehow. And that's what companies want you to do, not import some data set and do pip install, use something and show, wow, amazing results. I like to say that there are two big mistakes that data scientists do in this field. One is not appreciating the data in data science, and the other is not appreciating the science in data science. People often overlook data. It's not very cool. I remember in the previous program, I was telling the story about Ian Goodfellow, one of the very leading figures in the deep learning community, and he mentions that he was interning at Google. They were looking at street signs and trying to infer that this sign says 768 for automatic understanding of images. And they got to like a glass ceiling and they couldn't get past, I don't remember the number, 94%. For months, they looked at that and tried and many different methods. And then they went back to the data and realized that they had a bounding box algorithm that cut the number from the bigger image, and it cut it incorrectly. So 7 looked like 1, okay? And when I was telling the story, Doron from the previous class was saying, you already told us the story. And I said, okay, so I have like 8 more times to tell it to you until you finally get it. And the science aspect is very related to what was said before. It's kind of like a scientific way of thinking, of coming up with an hypothesis and improving it, and trying to prove it that it's wrong. So your model is your hypothesis about the world, and you can do your error analysis and try to see where the model, your hypothesis, doesn't fit the world, and try to improve it. As data scientists, our work starts when our first model ends. Okay, this is where we actually need to do things like doing the fit. Predict of scikit-learn doesn't really require you. Machines will do it better. Coming up with the next model is where data scientists really need to work.